Good day, students. You want to solve problem involving internal resistance in an electric circuit. What you need to know is that when you are talking about battery in a question, it involves more than one cell. It involves combination of two cells to give us a battery. Okay, let's see. And a battery of EMF two cells give us a battery, 12 volts. Internal resistance R equals 1.5 ohm. It's connected to an external resistance. Don't forget that this is positive terminal and negative terminal. And it's connected, current flows through the positive terminal, connected to the external resistance, which is given to us as R equals 3 ohm. Okay, you have it like this. Current flows back and enter through the negative terminal of the battery. And don't forget that when current flows, there will be terminal potential difference here at the external resistance, and there will be lost voltage at the same time in the battery. And the lost voltage equals V subscript R, which is I current multiplied by the internal resistance of the battery. The terminal potential difference V subscript capital R because current multiplied by the external resistance. And don't forget that our EMF equals the terminal potential difference plus the lost voltage. And what's common is current, capital R plus small letter r. You now have your E, which is EMF equals I into capital letter R plus small letter r. This is very important formula. Since you are looking for current flowing in the circuit, divide both sides by R plus R, R plus R. This cancel out. You have the current to be equal to EMF over R plus R. And don't forget that our EMF equals 12 volts. Your internal resistance for the battery, external resistance value is 3 ohm. Okay, now since you have it like that, your with 12 divided by R, which is 3 plus internal resistance 1.5 equals 12 over 4.5. When you divide it, you have 2.67 ampere. 2.67 ampere. Okay, that's the current flowing in the circuit. The second question, the P part, says the potential drop across the 3 ohm resistance. Potential drop across the 3 ohm resistance. V, you see that the external resistance is 3 ohm. VR equals current times the external resistance value. What's our current? 2.67 multiplied by 3. You press your calculator, you have 8.01 volts. We asked two questions there. The second one, we have to look for the potential drops in the internal resistance, and it's in the battery. We have V subscript small letter r equals to current multiplied by current in the circuit multiplied by the internal resistance of the battery. which is 2.67 multiplied by 1.5. When you press your calculator, you have 4.01 volts. And the C part, the terminal voltage of the battery. The terminal voltage of the battery. Don't forget that your EMF equals to the terminal potential difference plus the loss voltage. And you're asked to look for the terminal potential difference, which is the terminal voltage of the battery. Make the terminal potential difference or terminal voltage the subject of the formula, which is the capital letter V, and E equals E minus small letter v, E minus loss voltage equals terminal potential difference. If that should be the case, your terminal potential difference equals E minus loss voltage. What is terminal potential difference? What is the electromotive force? You have the 12 minus loss voltage. You have it as 4.01. When you press your calculator, you have 7.99 volts. Okay. Yes, the D part of the question told that the reading of a voltmeter connected across the battery in the open circuits. Okay, and the reading is that the voltmeter reading voltmeter connected across the battery terminal we read the battery terminal in open circuit, that is when it's not connected to the external resistance. In open circuit, that's what it means. We read the EMF value of the battery, that is 12 volts. To read the EMF value of the battery when it's not connected to the external resistance. That was saying that what will be the reading of a voltmeter connected across the battery in open circuits. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.